Okay, so what we're looking at here is an example from the 2021 exam of an implicit differentiation problem. And they seem to be putting these on the exams more and more, so this is a good one to look at. Hopefully everything makes sense as we go through it. So let's just jump right in. The problem says, consider the function y equals f of x, whose curve is given by, and then you'll notice we have a problem that has y's and x's mixed together for y is greater than 0. So the first thing says, show that dy dx equals this right here. In other words, find the derivative. Well, in order to do that, we're going to have to use implicit differentiation here. So I just take the derivative a term at a time, and anytime we take the derivative of something with y in it, we write dy dx after it. So I get 4y dy dx, the derivative of 6 is 0, and then I have to use the product rule to take the derivative of y times the sine of x. So I go first times the derivative of the second, plus the second times the derivative of the first. So that's the first step for implicit differentiation. Then you move everything that has a dy dx to one side and everything else stays on the other side. So in this case, I'm just going to move everything with the dy dx over to the left, and then I've got y cosine of x left on the right-hand side. Then I factor a dy dx out of both of the terms. So I'm going to factor dy dx out here. And then I'm going to divide by what's left over. So I've got that equal to the cosine of x. So then I divide by what's in the parentheses over on the right-hand side. I get 4y minus the sine of x, and I did exactly what they wanted me to, so letter A is all done. Letter B says write the equation for a line tangent to the curve at the point 0, 3. Remember, anytime we are asked to write the equation of a tangent line, we use this formula. And they give us an x value, that's easy. They give us a y value, that's also easy. I just need to find the slope. Well, in letter A, they told us what the derivative was. They told us that the derivative was y times the cosine of x. So I'm going to have y times the cosine of x divided by 4 times y minus the sine of x. Now, technically, you could just plug that in right there for m. That is correct. If you want to simplify it down, the cosine of 0 is 1, the sine of 0 is 0, and then these square root of 3's are going to cancel out. So what I really have is y minus the square root of 3 is equal to 1/4 times x minus 0, or just times x. There's your equation for your tangent line. They didn't even ask us to do anything with it. They just asked us to write the equation of the tangent line. Letter C says, and this is where I think this problem actually gets really difficult. C and D are very hard on this problem. For between 0 and pi and y is greater than 0, find the coordinates of the point where the line tangent to the curve is horizontal. Well, in order for us to have a horizontal tangent line, the derivative has to equal 0. So I have to have y cosine of x over 4y minus sine of x, and I need that to equal 0. The only way that a fraction is equal to 0 is if the top of the fraction is equal to 0. So I want to try and solve this if y is greater than 0. In other words, the y part is never going to be equal to 0. So what this is really asking is, where is the cosine of x equal to 0 between 0 and pi? Well, there's only one place where it's equal to 0 between 0 and pi, and that is at pi halves. And that's just, if you know your unit circle, that's where the cosine, where the y, or excuse me, where the x value is equal to 0 between those 2 points. But it wants the coordinates. It doesn't just want the x value, it wants the y value as well. So I have to take that pi halves and plug it back into my original function to find out what the y value is. So I get 2y squared is equal to 6 times y times the sine of pi halves, which is 0 actually, or excuse me, 1. So I have to solve this equation now. So I get 2y squared, I'm going to minus the y over to the other side, minus 6 is equal to 0, which means I have to factor this. So I'm going to get 2y and y, and I'm going to have minus 2 and plus 3. So I look and I'm like, okay, what are my two different y values here? I get y equals negative 3 halves and y equals positive 2, but in this problem it says that y has to be greater than 0. So negative 3 halves is out as an answer, and the only point where the line tangent to the curve is horizontal is pi halves and 2. The reason why I don't love that problem is there's an awful lot of algebra involved. Letter C says determine whether we have a max, a min, or neither at the point found in part C. Now we already know that that is a critical point because we already found that the derivative was equal to 0 at that point. So I meet my first criteria of having a max or a min. The problem is, in order to tell whether or not we have a max or a min, we need to see if our function is concave up, concave down, or neither at that particular point. In other words, I have to take the derivative again. And I have to use the quotient rule, and it's going to be awful here. So I'm going to have bottom times the derivative of the top. In order to take the derivative of y times the cosine of x, again, I'm going to have to use the product rule. So first times the derivative of the second, plus the second times the derivative of the first. And the derivative of y is dy dx. That's just the first part, minus the top, y cosine of x, times the derivative of the bottom. That's 4 dy dx minus cosine of x, all divided by the bottom squared. So I'm going to get 4y minus the sine of x squared. Now that's my second derivative, but I'm not even done yet. Now I have to take the point in question that I got from letter C, which is pi halves 2. So I have to take pi halves and 2, and I have to plug that in everywhere that I see y and x. So I get 4 times 2. In fact, you just know what you're supposed to do here. I'm not even going to write it all out. Because honestly, most people at this point would be like, whatever. I don't know what I'm supposed to do. Anyway, when you do plug that in, you get negative 14 over 49. That means the value is a negative number, which means my original function is concave down. If you think about it, if I have a critical point and my original function is concave down, what I have there is a maximum. Unfortunately, I thought this problem started out okay, and then C and D, especially D, there's a lot going on. It's really rough. Those were ones that if you can get them, that's great. If not, hopefully you can get some points along the way on this problem. If you have any questions about this one, please let me know.